All right, welcome everyone. I am JJ. Let's come in and tackle an example problem. So this time we have some cargo ship here. It is being towed by two tugboats. The tugboats are attached by cables A, B, and AC. And we know one of these. We know the vector for TAC as a Cartesian vector. We know the force in AB is 6,300 pounds. We're going to come in and try to say, let's get TAB as a Cartesian vector. Then determine what's our TAB plus TAC, what's our resultant of these two. What's our magnitude of that resultant? A unit vector that points in that same direction as our resultant is going to be that very final step in here. And then we're given coordinates of A and B, really just to help move everything along. So we're stepping through this. To get to my resultant's unit vector, I know I need the resultant vector divided by its magnitude, which we're kind of asked for both of those things. To get my resultant, I need TAC, I have that. But I'll need TAB as a Cartesian vector, so I need to get there. To get TAB, and that's also one of my answers, but to get TAB as a Cartesian vector, I'll get its unit vector times a force. To get that unit vector, I want the position vector divided by its magnitude. So it's going to be my first two steps. Let's get the position vector and its magnitude. So we'll come over on the left here and say, my first step, I need to find RAB. My position vector that goes from A over towards B, that same way that my force is pointing. B is the tip of this, A is the tail. So I'll do the coordinates of B minus the coordinates of A. Or this is negative 45 minus 0 will be negative 45I. 110 minus 20 will get me to plus 90J. Negative 5 minus 35 will give me to plus to minus 30K. Minus 30K. And my distances in here match my coordinate distances. Feet. If I have that, I can get the magnitude. My magnitude of RAB. Anytime I'm doing the magnitude, I'm looking at the Pythagorean theorem. So the magnitude of RAB is the square root of my I component squared, 45 squared, plus the J component squared, 90 squared, plus 30 squared, that K component squared. Or this works out to get me 105. If I have these two, I can get my unit vector. A unit vector is a position vector divided by a magnitude. Really, a unit vector is any vector divided by its magnitude, gets us a unit vector in that same direction. If I come in here and I get my UAB though, I could really just say, well, this is my vector RAB divided by the magnitude of RAB. Or this is, I can fill in pieces here. Negative 45I plus 90J minus 30K. Divided by the magnitude we just found was 105. And the units on that are also feet. But I have feet for a vector divided by feet gets me a unitless thing coming out. That should always be true. Unit vectors have no units. But my answer here for UAB is going to be UAB is equal to 45 over negative 45 over 105 is negative 0.429. 90 over 105 would be plus 0.857. 0.857. That was I for that first piece, J for the second. And then finally, negative 30 over 105 would get me negative 0.286K. Again, we're unitless in here. But I can take that unit vector and multiply it by the magnitude of my force to get my force vector. I'm looking for TAB, express TAB as a Cartesian vector. So this will be our first answer in here. TAB as a Cartesian vector is the magnitude of my force. We're given that 6,300. So 6,300 times our unit vector times negative 0.429I plus 0.857J minus 0.286K. Or my force vector, TAB, is going to get me to 6,300 times 0.429 is negative 2,700. 6,300 times 0.857 will get me to plus 1,000 or 12,000 J. And then 6,300 times 0.286 is going to get me to, I did add in a 0 here, didn't I? Nope, it's 12. It is, I'm reading the wrong line. Minus 2,700. This one is plus 5,400 J. 6,300 times a negative 0.268 will be minus 1,800 K pounds. And if we want to check that work, we could do it a little bit by saying, what's the magnitude of this? The square root of 2,700 squared plus 5,400 squared minus 1,800 squared should get me 6,300, because the magnitude of a unit vector is 1. And with this known, I can move on and say, well, let's figure out what's my resultant force. My resultant force over here, let's call that FR, should be the two vectors I'm adding together. I'm adding TAB and TAC. Is TAB plus TAC. Or that resultant force should get me, well, let's add up our two I components. I had negative 2,700 from TAB, and then I'm told TAC is 2,100 plus 2,100. That's my I piece. We can come on and get my J piece. So plus 5,400. TAB was given as TAC was 6,600. So plus 6,600 plus 6,600 J. And then we'll go to the next line to finish that up. Plus our K terms. A negative 1,800. TAC was 4,200. Negative 4,200. K. And our units in all of that are force, pounds plus pounds. This is still pounds for us. Which means our resultant force, we have FR. Should get me to negative 600I plus 12,000, what I tried to say earlier, J, minus 6,000 K. And again, our units here are our force units. We're in pounds. Or if we wanted to, we could switch that into kips. Negative 0.6 plus 12 minus 6 kips. It's the same thing. It's just a unit conversion difference. And finally, if I have that, or almost finally, I can get the magnitude of this. My magnitude of the resultant. Just like always, we're doing the Pythagorean theorem. 600 squared plus 12,000 squared, I squared plus J squared plus K squared plus 6,000 squared. Or my magnitude of the resultant, FR's magnitude, is 429.82 pounds, which is my second to last answer. The very last thing I'm asked to get in here is, what's a unit vector that points in the same direction? Well, over here, I went from a unit vector times the magnitude of my force, got me a force vector. Here I have a force vector and the magnitude of my force. I can just reverse this process. My unit vector, U sub R, should be my force vector, FR, divided by the magnitude of FR. And I have both of those pieces. So we'll show our work and document what we're doing here. But I have negative 600I plus 12,000J minus 6,000K divided by the magnitude, 13,429.82. Again, I technically have pounds on the top, pounds on the bottom, gets me a unitless thing coming out here. My UR. would be equal to, let's make my r look like an r. My UR as a vector, a unit vector, will be negative 0.044 plus, or 0.44i, plus 0.894j, 894j, minus 0.447k, which would be our final answer on that. One final check we could do, my unit vectors always have a magnitude of 1. Not just mine, all unit vectors do. If we check this, we should have a magnitude of 1. And one really quick thing, because I see this happen wrong all the time, if any one of these components has a magnitude greater than 1, something's wrong. Because if this is like 1.25, no matter what I do, I'm not going to get a magnitude under 1 if one of my components is over 1. We should at least be able to gut check that and recognize something's wrong if we're getting bigger numbers than 1 in there. But hopefully this is a useful video for you. If it was, hit those like and subscribe buttons. Stick around, watch more videos. Let's get you an AOJJ.